Okay, right now I'm going to make a video of the Born-Haber cycle for calcium fluoride. Somebody sent me this problem, and I think the easiest way to answer it is with a video, and I'm just going to share it with everybody so everyone can benefit. And just so you know, this is definitely a hard problem, okay? It's not easy. I wouldn't expect you to be able to um, get this your first time off. It's going to take a little work, a little practice. I know we're running short on time, but I do have office hours coming up soon. Anyway, there's a lot of information here, some of which we need, some of which we do not need. Most of it we do need, but not all of it. All right, so where I always start with these lattice energy problems is I just start by writing the overall net reaction. So we have calcium solid plus fluorine, diatomic fluorine, going to calcium fluoride. And we're given the energy of this reaction. And again, this is the overall net reaction. That's negative 1128 kilojoules per mole. And all of these are kilojoules per mole. I'll probably just stop writing that just because it gets a little tedious. So that's the overall net reaction. That is an exothermic reaction, so that is going to go down. And we need to really get to the lattice energy, okay? That's the whole goal of this. So let's write in the lattice energy, and it's usually a much larger value. Not that you would necessarily know that, so I'm going to make it a larger arrow. It's always exothermic. I don't know what that is. Anyway, the lattice energy for this, remember we have gaseous ions forming a solid ionic compound. So we have calcium 2 plus gas plus 2F minus gas, giving us calcium fluoride, CaF2 solid. Okay, and the energy for this, the delta H, really is what we're trying to find. And notice these both stop at the same place as long as I draw everything like that. But notice the calcium does not look like that calcium. The fluorine does not look like this fluorine. So that's what we're trying to do, is turn this calcium solid into this calcium 2 plus gas, turn this fluorine, this F2 into this 2F minus gas. Okay, so that's how we will proceed. All right, so the first step, I'm just going to deal with calcium first. I'm going to ignore fluorine for a minute. So let's do the first step for calcium. And then the first step is to turn the calcium solid into a gas. So that's sublimation. So Ca solid plus, I'm sorry, not plus, goes to Ca gas. And that's sublimation, and we're given the energy for that is 178 kilojoules per mole. All right, so that's gas, but we also need ion out of the calcium. Okay, we need to have a 2 plus charge. We can only do that one electron at a time. So we have calcium gas going to calcium plus gas. And this is what we call the first ionization energy. Okay, plus an electron. And that's also endothermic positive heat of reaction. And that is 590 kilojoules. I said I was going to stop writing it. I'm going to stop writing it. Okay, 590 kilojoules per mole. Next step, we only have a plus 1, we need a plus 2. So we're going to take that calcium plus 1, and we're going to, it's a gas still, we're going to pull off another electron, calcium 2 plus. This is the second ionization energy. Okay, and we have a value there of 1145, again, kilojoules per mole. All right, that's it for calcium, because you'll notice now we have calcium 2 plus gas, and we have calcium 2 plus gas. I'm done with calcium. I'm going to just leave it alone from here on out. Okay, so now we got to deal with the fluorine. First thing we got to do is break that fluorine-fluorine bond. So we have the F2 gas that we started with way down here, down there, and we got to break that bond. So we get F we get 2F gas. Okay. And we're given the bond dissociation energy, which is what this is. That's 159 kilojoules per mole. And if you need to, just go back to the beginning of the video, jot down some of those values or take a picture or whatever so you can follow along with me. All right. Next step. There's only one more step, actually. Oops. Let's bring this all the way over. Final step for this process is we're going to try and end up right there. We have to add a couple of electrons to fluorine. Why a couple? Actually, we only have to add one per atom, but we have 2 moles. So what we have here is 2F gas plus 2 electrons, and that gives us 2F minus gas. And that is electron affinity, okay? But we did 2 moles. And remember, electron affinity, the first one, is almost always negative. And for 1 mole, it's negative 328. So for 2 moles, it's double that. Okay, makes sense. We did double it, so we got to double it in both places, the value and the equation. So now that's the Born-Haber cycle. Okay, that's the finished Born-Haber cycle. But that doesn't give us the answer for this delta H. Oh, and notice too, let's just make the point. We have 2F minus gas here, and we have 2F minus gas here. That's how I know I'm done. Okay, and I've made CaF2 solid and CaF2 solid. I realized I forgot to put the solid on that though. So let's go ahead and jot that down. There we go. Now what I'm going to do is I'm going to add all of these guys up and figure out how to solve this problem, okay, to get the lattice energy. I'm just going to start by writing all of these energies down. So I'm going to start with calcium, or all these equations and their energies. Calcium solid going to calcium gas. And I'm going to write the delta H's, and they're going to be in kilojoules per mole, so I don't have to keep writing it over and over again, okay? That is 178. Next step, that is the calcium gas. And I'm just copying down from above, okay? I'm not doing anything new. Calcium plus gas plus an electron. That's 590 kilojoules per mole. All right, next step. If we look up here, it's the second ionization energy step. So we have calcium plus gas goes to calcium 2 plus gas plus an electron. Okay, that's 1145 kilojoules per mole. Next step, we move on to the fluorine, bond dissociation. F2 gas goes to 2F gas, and that is 159 kilojoules per mole. Next step is 2F gas, this is the electron affinity, plus 2 electrons gives us 2F minus gas. And that is 2 times negative 328. Okay, and I'm leaving it that way. You can very obviously calculate that out and write the value down. I'm leaving that way, so you see that it's the 2 times that value that you were given at the beginning of the problem. And then I'm going to write down my lattice energy. Step Ca2 plus gas plus 2F minus gas gives me CaF2 solid. And what's that value? We don't know. We could call it a question mark, we can call it X. I just like to use X. And then what will all this add up to? this will all add up to our overall net equation. Okay, and we'll do that, show that in just a second. So Ca solid plus F2 gas gives us CaF2 solid. And that value is negative 1120. Is it 1128 or 22? I think I wrote the wrong value here. That's negative 1228. Sorry about that. Oh gosh, I got it written wrong in a couple places. Negative 1228. Okay. Negative 1228. All right. So let's see how this all adds up. I want to get through this video. Okay, calcium stays there. Calcium solid. Calcium gas cancels. Calcium plus gas cancels. Calcium 2 plus cancels. Gas cancels. These two electrons, they cancel there. F2 gas, that stays. 2F gas, that cancels. 2F minus gas, that cancels. And that stays. Okay. So everything should be fine now. And all we're going to do is add this all up. So we have 178 plus 590 plus 1145 plus 159 plus 2 times negative 328 plus x is all equal to negative 11, 12, I wrote it wrong on my notes, that's my problem, 1228, so we simplify, 1416 plus x is equal to negative 1228, x is equal to negative 2644 kilojoules per mole, and that is our lattice energy. And hopefully I didn't screw up with the 1228 versus 1128, but that's just simple arithmetic. You should be able to figure that out. If you can't, email me. All right, I hope this helps. And by the way, if this is difficult, like I said, that's okay. This is supposed to be difficult. So just work through it, figure out the steps.